Yeah, hello everyone. My name is Victoria, and I'm going to welcome you to the last presentation of today. I'm working at the Center Construction Robotics in Aachen, and I'm going to give you some insights about implementing communication infrastructure on site to enable automation on construction sites. So first of all, why do we want to implement communication infrastructure? As you can see, there we have an increasing demand for connectivity on site, not only to communicate with existing stakeholders and trades, but also if you think about future and interlinked machines and increased use of data and sensors. So somehow this data needs to be sent on site and used, which leads then to the construction 4.0, which already was mentioned. On the second part, why you have to investigate on that is that construction sites are super unique. So everything is not the same on one side to the other side, and you have different requirements. Because if you think about a construction site for a railway is different for the requirements for setting up the infrastructure than if you're building a high-rise building which only is locally. So these all three leads us to that we want to set up communication infrastructure inside. And if you do so, it has multiple advantages. So as I already said, you have the enhanced interoperability of current stakeholders, machines, sensors, which then leads to a seamless information flow, which also is impacting not only the enabling of robotic processes, but also increased safety and productivity. So let me shortly explain you how our approach. First, we had a look on what communication requirements are actually on site and also what network technologies already exist. The second, we had a look at the construction characteristics which impacts the network setup. And the third step is a validation of a 5G network on our construction site in Aachen, as we are having a reference construction site. So first, the overall communications which already exist on site. So we have the human-to-human communication. We have the human-to-machine, but also machine-to-machine. And these three different categories have different requirements when it comes to network, because the data amount is different, the latency requirements are different. This has to be taken into account when selecting the appropriate network. On the second base, you have the existing network technologies, and they differ in terms of range and also data rate. So depending on what you need for your use case, you then select the one which is most suitable for you. And in our case, we had have a focus on 5G, as it is or has low latency, has higher bandwidth, and it enables machine-to-machine communication, which is also then enabling automation and digitalization on construction sites. So that was the first part. The second part, we had a look what construction site characteristics actually impacts the network setup. As I said in the beginning, of course, there is the construction layout, because you have to think about what do I have. And I come to the antenna position in specific in the next slides, because as I said, we have a 5G network, and the antenna position where you put it on site is also influencing the coverage and signal quality. And this is also influenced by dynamic or fixed construction obstacles. So if you have different materials which may influence the coverage and also the signal quality, but also, of course, budget and time is always also impacting what you want to set up on site. So let me quickly, or not quickly, but based on these characteristics, pick the antenna position as an example, which we go through here now, because you can see now various networks set up and their impacts. So if you see on the left side, we are now at the early stage of construction. So the excavators are doing their job. And if you think about of course, we can also think about these two machines communicating and working independently, but maybe we don't have to go that far, actually. If you think about different sensors are here, which transfer data, you have to see where I put my antenna to collect this data. So at the first stage, you can maybe choose a container or a fixed position at the side of the excavation hub as a place for the antenna position. But then if you think about the next phase where you actually have, for example, a tower crane, which is mainly normally in the center of the construction site, which could then serve as a really good point to establish the 5G antenna, because the coverage is quite good all over the area where it is required. As a contrast to that, I think that it got a bit moved because this antenna actually has to be on the container here. But in contrast, you see if you put the antenna, for example, on the container, the antenna on the container, not on the central position of the crane, the coverage might not be sufficient to cover actually the area where you want to select some data or transfer data. And the last one, what I wanted to highlight is the construction progress and also the construction material. Because if you think about, you take the antenna on the crane, still the existing construction progress has an impact on if you still really get signal here, maybe behind the building. So if you're implementing network infrastructure, you always have to think it in alignment to the construction process. So as I said, the last step is now what we are currently doing is setting up a 5G infrastructure on our reference site. And we actually took our tower crane, which is positioned on our reference site, to be equipped as an antenna. And we have, as you can see here, this is a real image, the 2 radio units and the 2 antennas on site. And we are now currently investigating this network with different use cases and see the performance, because it is also different from applying 5G in a production and then applying it to construction. And also we have some facing some challenges with the network and in general the setup. So it's quite interesting now to see and apply the network on the construction site. Yeah, so let me summarize quickly. It is what we identified is that you have to see that you match the use case with the network technology which is available. Because if you only want to transmit maybe a weather data or a state-of-the-art data, construction state-of-the-art picture once a day, you don't need expensive 5G equipment. But if you think about machine-to-machine communication, reliable, secure data, then the requirements to the network increase. And the second thing, which is quite important to highlight, is that the network itself is easy to deploy and maintain, because if nobody is actually capable of using it on site, it won't be also applied. So in future research, as I said, we focus on applying 5G on our reference site with different use cases and see the network performance in general. And also we were looking into what different communication requirements match to what network technologies. As I said, you don't need 5G for everything, but also LoRaWAN may not be the solution if you want to enable robotics on site. Yeah, so I think that's all from my side. Thank you very much, and yeah, have a great evening. And